Okay, in this section, section 8.5, we learn how to solve quadratic inequalities. I'm going to show you two different problems in this video clip. I'm going to show you a less than and a greater than because they make a huge difference on how you set them up. Okay, with a less than inequality, the first thing you want to do is get everything on the same side. I would keep all the variables on the left. It makes it easier to do your solution in interval notation. So the first thing I'm going to do here is add my 3. Again, because you are solving this and you have a quadratic term and a linear term, you are going to have to do some factoring. So you can do trial and error, you can do factor by grouping, whatever way you learn best. I'm going to ignore the inequality part right at the moment. Okay, the way this would factor is 4x and x, and then I need a 3 and a 1, and everything is positive. Okay. Now, if I were to ignore this for right now and act like this were an equation, then the answers I would get when I set this part equal to 0 is negative 3 over 4. When I set this part equal to 0, it's negative 1. Okay, what you're going to do then is take these two numbers and you're going to draw a number line. Okay, of course, put the smaller number first. Okay, and what you're going to do when you're solving a quadratic inequality is basically called the test point method. You're going to take points in each region and you're going to test it into your original equality and see if it's true or false. And that's going to tell you where your solution lies. So I'm going to pick the numbers, let's see, I'm going to use negative 2 in this region. This is kind of tough because they're so close together. I'm going to use negative 0.8, and then I'm going to use 0 over here. Okay, when I go back in and substitute them in, I'm substituting in to the original, or you can substitute them in right here. It really doesn't make a difference. All right, when you plug in negative 2, I'm going to do this the easy way. Okay, I'm going to do 4 times negative 2 squared plus 7 times negative 2, and I get positive 2, okay, over on this side. Positive 2 is definitely not less than negative 3, so this region is false. Okay, when I test the negative 0.8, I'm going to do 4 times negative 0.8 squared plus 7 times negative 0.8. Right, this time I get negative 3.04 on this side, which is definitely less than negative 3, so this region is true. If I type in 0, I'm going to get 0 here, and 0 is not less than negative 3, so this region is false. About 95% of the time, the regions are going to alternate like this. There are a few cases where they don't, but typically they will. You still want to make sure you check each region. Now, your solution is an interval. Okay, whenever you're dealing with an inequality, your solution can cover more than one possible answer. So when you go to write your answer, they're going to ask you to write it in interval notation. Well, with interval notation, you first look at this part. Okay, if this is strictly less than or strictly greater than, then you're going to have parentheses in your interval notation. If you have an equal sign, you would have brackets. Since there's no equal sign here, strictly less than, you're going to have parentheses. Now you start your parentheses, your first number that was part of your original problem. So I'm going to go from negative 1 all the way to the end of my true region, which is negative 3/4. Okay, kind of looks like an ordered pair. This is your answer in interval notation. That's telling you that any number between negative 1 and negative 3/4 will solve that inequality. Okay, now let's look at a greater than. Alright, here's another inequality. This is a greater than, and like I said, I just want to show you one of each. Now here, this type of factoring is a little bit easier. It's just GCF since we only have two terms. I'm going to factor out an x. And again, I'm ignoring the inequality part right now. If this were an equation, this would be one solution, which is 0. And when I set that equal to 0, I'd get 4. So the two numbers on my number line is 0 and 4. All right, now again I need to pick points in each region to test. So I'm going to use negative 1, 1, and 5. And it doesn't matter what points you pick as long as they're in the respective regions. All right, when I type in a negative 1, I get negative 1 squared, which is 1, and then this will be positive 4. So I'm going to get 5 here, which is definitely greater than 0. So this region, this time, is true. If I type in 1, I'm going to get 1 minus 4, which is negative 3, and that is not greater than 0. If I type in 5, I get 25 minus 20, which is 5, and that is greater than 0. So you can see these solutions are the opposite of the last one. The last inequality we did was false, true, false, and this one is true, false, true. And that's usually typical of these types of inequalities. This time your solution, since I'm going this way forever, I'm going to start my interval notation with negative infinity. And even though there's an equal sign this time, infinities are never included. They're always parentheses. All right, then I'm going to go to the end of the first true region, which is 0, and that's where I'm going to have the bracket. Okay, then I use my little union symbol that symbolizes OR, and then I'm going to start at my next true region, which starts at 4, and goes on and on forever, so to positive infinity. You always should go smallest to largest when you're writing interval notation. That's very, very important. So if you notice, negative infinity can't get any smaller than that, then 0, then 4, then positive infinity. So you want to make sure you write it in the correct way. So this is your solution for this type of inequality.